The questions that I took at school were chemistry, biology, maths, and geology. I did physics for my O levels, but because I wanted to study more environmental science related degree, I swapped physics for geology for my A levels. And they really helpful for the degree that I chose, because being a science degree, it was compulsory to do those subjects, and it meant that that I had the starting point to then to be able to develop them and increment my knowledge on those subjects, to be able to apply them in the real world, some real examples. So yeah, it was a great benefit. Currently, I'm researching soils. I work on urban soils. I work on what it's called carbon abatement technology. So it's techniques that we use engineering soils to enhance carbon capture for climate change, and also working within bioenergy and how we can complement bioenergy with carbon capture, so we can close the circle and make renewable energies more efficient. The main benefits of my research is that it's solution driven. We're trying to help address some of the societal challenges that we face regarding making natural resources more sustainable, and how we can make sure that we can do this in a way towards helping towards fighting climate change. And not only that, but also other aspects associated with that, like waste management and energy production and food security. So trying to find a way where you can complement those different aspects. Right, my career path, I started doing my O levels and A levels, well, the equivalent in Spain, in science. I wanted to do what you call here the triple science. Yeah. So I did my triple sciences because I've always really liked science, especially biology and chemistry were my favorite subjects. Following that, I applied to do a degree at Barcelona University in biology. But once I got into the chemistry lab, I really loved chemistry. But I could still do something with this, was biochemistry. The good thing was that you could spend your summers doing field trips and things outside university, and I spent a whole summer working in the Pyrenees studying biodiversity, so I went big time with ecology studies, and I loved that. And I realized that many of my university friends were doing Erasmus to go and study abroad for 6 months. But I realized that I didn't want to go and study for 6 months. I wanted to come to the UK to actually complete my degree here. So I came to the UK. They did they corresponded the subjects, so I could go straight into second year and study agriculture and environmental sciences. I spent my summers working in the labs, and I love being in the lab. It was a no-field foundation project in my second year, and that was the stepping stone for me to realize that I wanted definitely to be a scientist studying environmental studies. And through that, I engaged with the lecturer at the time, and he straight away offered me a postgraduate PhD in a European project within the subject of my degree. And from the PhD, I managed then to expand more in the chemistry work and develop analytical techniques, and that allowed me to go into become a researcher within a different department in the university, being a scientist, which I've done now for 11 years. Well, I think the more young people should study science, because we need more people doing research and innovation, so we can address some of the societal challenges that we are facing. I mean, we all know that we have limited resources, and the problems that we have with within the environment and energy and food security. So the more young people that want to study sciences and try to address those problems, the better. Yeah, I mean, it's a sign of a society that is developing well and is looking after their people. Yeah. To enter a career like mine, you have to really like your sciences. So obviously, for your O levels and your A levels, you should choose some of the subjects that would give you a broader aspect. So if you change your mind, you can still follow one or the other. So good A level results, and then once you go into university, try to get at least a 2-1. If best the first, to be honest, if you want to then become a researcher, because to apply for a PhD, a postgraduate degree, you need to have good results, and that would mean that you show that you are dedicated to it. In my current career, it's much better to work as a team. Some of the work that I've done previously is being solo, because I was developing analytical techniques, so I was on my own in the lab, but it was quite hard to see how you could apply them afterwards. In the current projects that I'm involved in carbon abatement technologies, because they are solution driven, to be able to reach an answer towards studies, especially on energy or sustainability, you need to have several approaches. So you would have people working on providing the robust measurements, then other people working on the models, and then other people working on the impact on society, engaging with the company. So you need to be part of a team and be quite open-minded, because sometimes, to get to understand the other colleagues' points of view and yours, you really need to be quite open-minded, and working in a team is much more fun as well. My future goal is to set up my own research team on carbon abatement technologies, so that then I can get more people involved in the work that we do. That also involves doing some more teaching in environmental sciences, so I can be able to get more students involved in the project and also provide them projects for the summer. The key skills would be you have to have perseverance, so that when things don't work out in the lab, you cannot really give up. You have to keep going. You also have to be quite creative and innovative, so you have to try to come up with new ways of how to address some of those problems, how to come up with some of those answers, either in the lab, experiments, or so forth. And you have to be a very good team player, because you always have to work with other people sharing the lab facilities, so doing field work together, and excellent science communication skills. Then you need to be able to communicate the work that you've done at all levels, at academic level when you go to a conference and write a paper, but also when you then give a lecture or engage in a public event. Well, regarding renewable energies, there is not a silver bullet, so you cannot just say right. And also it does depend on the geography. I mean, depending on a case-by-case scenario. So maybe in the UK, wind energy would have a much better application than maybe solar energy, which, in a country like mine in Spain, that's one of the answers. But the one that I can see, obviously from my own research, that it can be applied at all different levels in all countries is within bioenergy. I would like to see more bioenergy applications. We can do that through included with waste management, things like anaerobic digestion, which is one of the ones that I would like to see more of, and then the use of bioenergy for fuel production as well. Well, the world population is increasing, and most of the population live in urban environments. So we need to make them. We need to make those environments suitable for for a growing population, where not only you need buildings to live in, but you need spaces where you can for recreation purposes, but also to grow food. So we're looking into improving ecosystem services in urban environments to provide not only green spaces for recreation, but also green spaces where you might want to have allotments, so you can grow food in the city as well. So that's one of the reasons why we're looking into improving the ecosystem services in urban environments. Well, this is the dirty lab where we do all our sample preparation. So when we go into the field and we have to bring back our samples, this is where we dry our soils and then we'll seed them. We would use equipment like that one there, where you can stack up all your sieves, so you can do all your particle size distribution before you do your analysis in the lab, and then we can use the grinder then to grind some of them into a fine powder. This lab is used for the geoscience group, so we do soil analysis but also rock analysis. So if you need to go into the field and you have some rock samples and you need to cut them, this is all the cutting equipment. So you can cut your rocks to size depending which analysis you do. And as you can see, this one here, you can cut them into different shapes, depending what you need to do with those samples. Okay. This is our thermal analysis lab, where once we prepare the samples, we can analyze them with this equipment here, which is a thermal analyzer, which looks into the weight loss and the energy change of materials as you heat them up, looking into endothermic and exothermic reactions and how stable materials are in the environment. And it's coupled to something called a particle mass spec, which analyzes the gas being evolved, and also an isotope mass spec, where we can look into the carbon and the nitrogen ratios of those materials. We use that to understand the carbon and the nitrogen cycles in the environment. Within the work that we do in urban soils, once we grind the samples into a powder into the prep lab, we can put them into the thermal analyzer. This is the kind of results that we will get. The equipment is currently running, and you can see that as we heat up the sample, you remove some water, then you have a weight loss associated with organic matter materials. So if I show you this one, this is one that I brought earlier, the sunburns. You heat up your sample and then you remove the moisture of the water, giving you an endothermic reaction that you need to remove the water. Then as the sample heats up at higher temperatures, the organic matter would then, you will need an exothermic reaction. It will give heat from the labile material, like green material, like leaves. Then you've got the woody materials, and then you've got things like charcoal, black carbon, and those are exothermic reactions. So with high, it would give heat. Now the thing that we do engineering soils, we're trying to enhance the weathering of minerals, precipitation into calcium carbonate, which is a carbon form which is very stable, and for that you will need an endothermic reaction at much higher temperatures. And this is how we are actually engineering soils to enhance carbon capture through an increase in stable forms of carbon in the soil. The work that I do on bioenergy, we look into different feedstocks, biomass materials that we can use to convert them into energy. And we use things like pellets from oilseed rape, wood chip materials from different waste wood, or in this case is from anaerobic digestion, the fermentation of materials for biogas, and you end up with some of the solids. So once you get the energy out of those biomass materials, you sometimes end up with a residue, which is called biochar, which is like a charcoal material or an ash material. And this you can put back into the soil as a soil amendment to improve the soil quality to grow your crops. Those materials we also analyze with the thermal analysis to look into the stability of those materials back in soil, and also to look into the energy in those materials before you study them to get energy out of them.